Hello everyone. So in this video we will complete the assembly module. Okay, this video may become of 45 to 60 minutes. Okay, in this we also calculate the distance of the bars from coordinate. So first of all we need to draw the beam. Just in this sketch I am taking the stirrup as a rectangle. Okay, so no issue will be there because in analyze we have taken the stirrup as curved corner. It's just to calculate the distance and nothing more. So this is a cross section of our beam, and we know okay, this distance is 230 mm and this distance is 460 mm. Okay, the width and the depth we know. So let's take, this is the ordinate point, and from here to here let's take 25 mm. Okay, and this is the effective cover, we can say that, and here to here 25 mm. So we have calculated the position of this bar, that is in x direction 25, in y direction 25. Okay, now for second we will calculate this bar second. Okay, so name, if you can just name this bar. Okay, it will be easy for us. This bar is 1, this is 2, and this will be 3. Okay, so here we can write bar number 1, x equals to y equals to 25 mm. Okay, no problem. And for bar number 3, first we will calculate bar number 3. So we need to calculate distance from here to this point, and we know that this is also 25 mm. So this will be 230 minus 25, that is be 205 mm. So okay, in x direction, and similarly in y direction it will be 25 mm. So for bar number 3 we have bar number 3, x equals to 205 and y equals to 25. Okay, so we have completed this two bar. Now for middle bar, for this bar number 2, we need to find first the distance from here to here, and similarly from here to here. Okay, then we will just find the okay, if we get this value, then we will just add this value into this distance which we already have as 25. So we need to find the distance between these two bar. So we know that the total distance here is 230 minus 25 from this side. This is 25 minus 25. Again we know that this distance is 25, so minus 25 from this side, so that will become, I think, 230 minus 50 will be 180 mm. So this is 180 mm, and this will become 180 by 2, that is 90 mm. So we can calculate this. 90 plus 25, that is 115 mm from the coordinate. So for second, x equals to 115 and y equals to again 25 mm. So we have calculated bar number 1, 2, 3. Okay, we don't need this number, we have already calculated. Let me delete all this. Okay, for top bar we need to first find the distance of the stirrup. So we know this is 25, and let me change the color. And this distance from here to here, it will be half the diameter of 16 bar, that is 8 mm, and we need to find this distance. Okay, so this distance, let me change the color for better understanding. Here you can see from the end of this bar to the mid of the stirrup, that will be 4 mm, because the total dia of the stirrup is 8, so half the dia will be 4. So we need to find this distance, so it will be 25 from this distance minus 8 mm, that is heat 8 this distance minus 4 mm, so it will be 25 minus 8 minus 4, 13 mm. So our position of the stirrup, here we can write will be x equals to y equals to 13. Okay, now let assume this is the bar number 4 and it is bar number 5. To calculate the position of this bar, what we can do? Okay, let's take the similar distance. Effective depth of this bar is 25, so here it is also 25. So in x direction we have 25, in y direction what we have, that is 460, depth of the beam minus 25. So let me remove this part first. So from here what will we have, 460, that is depth of the beam, minus 25, that will be 435 mm. So for bar number 5, sorry, bar number 5, okay, 4. So bar number 4, what we have, 435 in y direction and 25 in x direction. So let me write it here. 4 number bar, x equals to 25 and y equals to 435. Similarly, for bar number 5, we get the value of y, that is 435. Okay, the y distance will be same for both the bars. Now we need to calculate the x distance. For x distance, again this will be 25. So 230 minus 25, this distance will be 230 minus 25, that will be 205. So x will be 205. Now at last we need to find the dimension of the stirrup. So for the dimension we have calculated, stirrup, we have defined the stirrup in part module. We need to find the dimension of the stirrup. How you can find the dimension of the stirrup? We have calculated that this distance is 13. This distance again is 13, and similarly this distance at the mid of the stirrup is 13. Similarly at the top, so we can find it. From here to here, 460 minus 13 from top and minus 13 from bottom, that will be 434 mm. Okay, I think I have just, let me check. Okay, at top we need to again calculate the distance. So what we can do, we know this distance is 25. Similarly this distance is 5 and this distance will be 4, and for stirrup we need to find this distance. Okay, so 25 minus 4 minus 5, that will be 16. Okay, because here we have 10 mm dia, this bar is 10 mm dia. So 460 minus 13 from bottom and 16 from top, what we will get, 431 mm. Okay, and in x direction the size will remain from here to here 13 and from here to here 13, because we will consider this bar for width, not this bar. Okay, so stirrup height, width equals to 204 mm and depth equals to 431 mm. So in next lecture we will assemble all the parts here by using this data.